Hi everyone, this video is going to focus on an optimization type problem. So with these given problems, you want to make sure you read carefully, make sure you understand the context, draw yourself a picture, and try to get everything in terms of one variable to make it easier for yourself. But let's just get started so you can kind of see what it looks like. So what we're going to do here is find the largest possible area given its boundaries. So we're going to draw a picture to represent this, but really we're looking for the dimensions of this object. So a rectangle is formed with the base on the x-axis and the top corners on the function y equals 6 minus x squared. Now I'm going to draw myself a picture here. So this is on a coordinate plane, and we know the base is on the x-axis, and then it says the top corners is on the function y equals 6 minus x squared. So if I were to draw, now this is not going to be pretty here, but it's going to look something like this. 6 minus x squared is symmetrical, and it is upside down, right? It's an upside down parabola. So what we're looking for is we're going to be creating a rectangle of some kind, if I can draw nicely here, where the corners are touching that parabola. Okay, so we know it's symmetrical, which is nice. So that means if I'm going to have a rectangle here, let's use a different color, and this is my bottom, I don't know how far it is from the origin. So from the origin to here, I'm just going to label as x, okay? But because this is symmetrical, I know that this over here has to also be x. So this total length I know has to be 2x. And then the vertical here, or the width, is, I'm just going to label as y. Okay, so here we want to find the largest possible area. So I know that the area of a rectangle is x times, oops, I don't know what I'm writing, is x times y. In this case, length times width. Except the length here is not really just x, it's really a 2x, as we defined in our picture here. So it's really 2x times y is my area for this rectangle that we have here. Okay, so, well, if you remember from the boot camp notes, anytime you want to do an optimization problem, you want to write everything in terms of one variable. So the problem that we have here is we have an x and we have a y. So in order, before I can do anything, I want to rewrite this in terms of one variable. Well, luckily I know that y is equal to 6 minus x squared. So what I'm going to do is I'm going to take this and I'm going to substitute that y with that. So really the area of this rectangle is 2x times my y, which is 6 minus x squared. So it represents the area of that rectangle. Alright, so before I differentiate, I am going to just multiply this out a little bit. So I get 12x minus 2x cubed. Okay, now because we want to find the largest possible area, we're optimizing, which means that we want the derivative. We want to find the derivative, and we want it set it equal to 0, because that would mean that that is a maximum, right? And the derivative of that max at that point would be 0. So I'm going to find a prime, and let's differentiate this. So this becomes 12 minus 6x squared, and I want that to equal 0. So let's see, let's solve that. So I get negative 6x squared is equal to negative 12. So x squared is equal to 2, which means x is the square root of 2. Alright, so if you look at what the problem's asking for, it's asking for the dimensions. Okay, so I'm looking for the dimensions of this rectangle. Well, I found what x is. I need to find what y is before I can find the dimensions. So I know that y is 6 minus x squared. So if I know that x is root 2, I know that y is 6 minus 2, which is 4. So if I'm looking at this rectangle again, okay, so here's this rectangle. Remember, the length is 2x, so it's going to be 2 root 2, And the width is your y value, which is 4. So the dimension of this rectangle is 2 root 2, so 2x, by 4. That is the dimensions of the rectangle with the largest possible area.